Welcome back, Calculus 2 students, to another math review. Here we're trying to find the integral of cosine x times cosine to the fifth sine x dx. In order to solve this integral, the first thing we need to do is a u substitution where u is equal to sine x, so that du can equal to cosine x dx, so that 1 over cosine x du is equal to dx. Substituting this back into the integral, we get cosine to the fifth u times du. Breaking this integral down further, we could get cosine to the fourth u cosine u du. We could also now perform a secondary u substitution, except this time we'll use v. It's equal to sine u just sine u. Then dv would equal to cosine u du, where 1 over cosine u dv would equal to du. Now that we get this, we would now have an integral of cosine to the fourth u dv. Why is there a u and a v in the same integral? I'll resolve this in a second. What we actually need to do is manipulate this cosine. So this could also be the integral of cosine squared u squared dv. What's the trig identity of cosine squared u? That would be 1 minus sine squared u squared dv. What's our v? Sine u. What does that mean? We can now replace sine squared u with v squared. No more u. What can we do now? We could FOIL this because this function is squared. This would leave us with the integral of 1 plus 2v squared plus v to the fourth dv. This should be a minus. Next thing we need to do now is solve for the integral of this, which would be, if we were to rearrange this term here a little bit, v to the fifth over 5 minus 2v to the third over 3 plus v. We're not going to add the c yet, but we'll add it in a little bit. Replacing the v's now, we get sine to the fifth u over 5 minus 2 sine to the third u over 3 plus sine u. I'm actually going to make a little bit of room up here to finish off this problem. So now when we substitute the x values back where the u's would be, we now get sine to the fifth sine x times 1/5. You can also put it over 5, whatever is preferable for you, minus 2 sine to the third sine x, 2 over 3 times sine to the third sine x, plus sine x plus c. And that is how you solve for this integral.